Huh? Hi. Today we just continue the lecture we started on motion in one dimension. But before I start proceeding, I just remind you of what we did so far in motion in one dimension. Just a recap, a quick recap. And then we move on to the new stuff. So if we want to just remember what we did so far, we talked about average velocity. And we said to find average velocity, V average, we need to know delta x over delta t. And delta x is the displacement over the time taking. So we need the displacement. And delta x is the x final minus x initial, t final minus t initial. Positions, negative or positive, which means the average velocity has a sign based on the delta x sign. So it could be positive, negative, or 0. Positive means the velocity to the right. The motion is to the right. Negative to the left. 0, no motion, or back to the same point. So here, no motion, or back to the same position or point. So this is about average velocity. Then we talked about average speed, AV, S average. And we said average velocity needs the distance, d, distance over the time taking. Delta t or t means the same thing. Distance, we said, is not equal to displacement. Because if they are equal, then there is no need for two equations, this average speed and average velocity. So there is no need for such a thing. So generally speaking, distance and displacement are not equal. But sometimes they are equal when there is no turning points, when the object goes in one direction. So the shortest between 2 points is displacement, and at the same time is the distance, but without taking the sign in consideration, because sometimes you go to the left, which is negative. So distance needed for average speed. Then we moved on and we talked about instantaneous velocity. Velocity instantaneous. And we said instantaneous velocity, we need the derivative of position function with time. So it's dx over dt, derivative. Now, how do I use this one? It means you should have a function. What is your function? Xt function. Position with time. Like, maybe I have 3t cubed minus 2t plus 1. The time, t, and x is the position. X is not displacement, position. So if I want to find the instantaneous velocity at t equal 1 second, as example, what I have to do? Xt function give the derivative. It's v. So v instantaneous is dx over, and this will be 9t squared minus 2. This is the instantaneous velocity at any time. So if you want it at 1, just substitute 9 minus 2, which is 7 meter per second. This is the instantaneous velocity. So this is the meaning of derivative. What is the other meaning of instantaneous velocity, or how can be found if you don't have equation? What we usually have, you have a graph. And the graph will be time with position. Let's say meter second. Whenever you have a graph and you are asked about the instantaneous velocity, let's say this is my function, xt function, and I want to know at this time t, what is the instantaneous velocity at t here. So what I have to do, the other meaning of derivatives mathematically means the slope of the tangent line for the xt graph. So v instantaneous meaning slope of the tangent line at a point where in xt graph. So this is the second method of finding instantaneous velocity. So here, as example, what you do, on this point, you just draw a tangent. And then once you draw the tangent, choose 2 points on the tangent and find the slope. The slope equal instantaneous, yeah, velocity. Now, the next thing we talked about after instantaneous velocity, we talked about instantaneous speed, S, instantaneous, yeah? And instantaneous speed, it's easy to be found. Just take the velocity, instantaneous, and remove the sign, which means the absolute value. Absolute value of instantaneous velocity. Because the speed always positive. Velocity sometimes positive, sometimes it's negative. Okay? Now, don't forget that when you have delta over delta, this means, mathematically means average rate of change. And what else? It means the slope of the secant line. Secant line. So in xt graph, if you want to find the average velocity, you need 2 points, yeah? And you connect them with a secant line. It gives you the average velocity. After speed instantaneous, we talked about average acceleration, AAV. And we said average acceleration needs a change in velocity, delta V over time. Okay? Change in velocity over time, which means is final velocity minus initial, final time minus initial time. Okay? And delta over delta means average rate of change. Average rate of change of velocity with time. And we said that before, that velocity has a sign. Average or instantaneous has a sign, positive or right or left. So initial velocity has a sign. Final velocity has a sign. When you subtract them, you have a new sign, yes? The new sign is the sign of the acceleration, which means acceleration, again, could be positive, negative, or zero. When the acceleration is positive, what does that mean? It means delta V is positive, not V. So the sign of acceleration doesn't give you the sign of velocity. It gives you the sign of the change in velocity. So when it's positive, it doesn't mean the velocity is to the right. It means the acceleration to the right. Acceleration, not motion. You could move to the right, your motion to the right, but your acceleration to the left or to the right. So it's not a rule that if the velocity is positive, the acceleration is positive. If the velocity is negative, the acceleration is negative, because acceleration doesn't depend on velocity sign. It depends on the change of velocity sign. Right, left. What does it mean constant? This means acceleration average is 0, means V final equal initial, which means the velocity is constant, not the acceleration. The acceleration is 0. And remember, if you're driving a car and you put it on the cruiser, what does that mean? You are not changing the velocity. So velocity is constant. So you are not accelerating the car. You are not speeding up the car, or you're not slowing down the car. So this is the last one. After average acceleration, we talked about instantaneous acceleration. And based on the mathematics, instantaneous and average, one is the delta, the other one is the derivative. So here is the derivative v with t, velocity with time. Acceleration instantaneous is the derivative of velocity with time, which means if you have a velocity time function, like the one maybe is 2t squared minus 1, and you want to find the acceleration at t equal maybe 1 second, acceleration is the derivative, and this is 4t. Huh? So acceleration at t equal 1, 4 by 1, 4 meter per second square. This is the instantaneous acceleration. Now, as we did there before, what is the graphical meaning of this derivative? Like the velocity? Slope of the? And which graph? VT graph. So acceleration instantaneous can be found from the slope of the tangent line at a point where in velocity time graph, in VT graph, in VT graph. So if I take the xt graph here, think of it as VT graph. I'll change it. Velocity time graph, t graph, okay? Now, what happens now? If I say, what's the acceleration at t? What I have to do? Draw a tangent at t. Take 2 points, and the slope will represent what? An instantaneous acceleration. So I think this is what we did so far. Just remember, sometimes we use the graphs to extract the information, sometimes equations, and you should switch between these two methods. And we have secant and we have tangent. Secant for average, tangent for instantaneous. And these are the definitions. Right. So this was a recap of what we did so far. Now we'll move on now in motion in one dimension. And let's say I want to take a special case of motion. What's this special case of motion? let's say we have motion with constant acceleration. Motion with constant acceleration. Motion with constant acceleration. What does this mean? It means, of course, we are still talking about an object moving on one dimension, not 2 or 3 dimensions. If you have an object moving in one dimension, and the object moves with a constant acceleration, it means the acceleration, A, equal to a constant value. A constant value, it means maybe it's minus 3 meter per second squared. This is the constant value. Or plus 7 meter per second squared. So this is the meaning of acceleration constant. Don't get it confused with velocity constant. The velocity here is not constant. The acceleration is constant. If the acceleration is 0, A equal to 0, it means velocity is constant. It's not changing. Yeah? There is no change in the velocity. So here acceleration is constant doesn't mean first acceleration is 0. It means it has a value, positive or negative, left or right. So when the acceleration is constant, what does that mean? Okay. It means velocity is changing. It doesn't mean velocity is constant. What we covered so far, 2 types of acceleration, average and instantaneous, okay? Now, what was the average acceleration formula? Change in velocity over time. Change in velocity over change in time. Instantaneous, dv over dt. Now, in this case, I'm saying the acceleration is constant. Which acceleration do I mean? Average or instantaneous? Average. What about instantaneous? Okay. Now, forget about this. Let's talk in general. If you have a constant value, regardless of what you call this value, a constant value, coming from a calculation, yeah? This constant value, when it comes from a calculation, what's the average for that value?
0, 0.
Why average? Yeah. All right, let's change the example. In this class, let's say you have grades, all of you, you got B in an exam. All, B, yeah? So what's the instantaneous here, value?
B.
Here?
B.
What's the average of the class? So when the value is constant, what can you say? The instantaneous and the average are the same. There is no difference between the instantaneous and the average. When the value is constant, there is no difference between these two concepts. This is generally speaking. So here, what can I say? Because the acceleration is constant, I can say that average and instantaneous are the same. So here we say instantaneous acceleration same as average, which is equal to constant value. I'm not here to calculate it because I have a value like minus 3 plus 7. So when I say the acceleration is constant and 7, what's the average acceleration? 7. What's the instantaneous? 7. No change. So,
Regardless of the positive or negative?
yeah, we talk about the value here.
But it's only
Value, but direction, of course, you keep the direction as well, either positive, because when I give you the constant, I have to tell you which side. I say constant minus 3 or plus 7, yeah? So I'm
instantaneous, it can be with direction as well?
of course, acceleration, instantaneous, average, both they have sign, yeah? It's not like this one has sign, this one doesn't. Acceleration generally, instantaneous or average, they both have signs. Right. So can I use this equation, average acceleration, for instantaneous acceleration or not? Yes. So I'll say instantaneous acceleration is equal to delta V over delta T. What is delta V? V final minus V initial. I'll keep the delta T instead of saying final minus initial, okay? Now we agreed that whenever we want to calculate an instantaneous velocity or acceleration, there is no need to put IN, yeah? So I remove the IN, but I mean instantaneous. And then multiply it by delta T, what you'll have, V final equal V initial plus A delta T. I just multiplied and moved the initial velocity to the other side. What do we see here? Equation, yeah? Initial velocity, instantaneous acceleration, which is constant here, one value. It's not changing. Time difference between initial velocity and final velocity, these 2 points, okay? Now, let's remove the delta T and put T. Remember, T means delta T. When I say, what's the time now? You say 2 o'clock, referring to a reference, 0 reference, yeah? So delta T means T. And what else do I do here? And instead of saying initial and final, I use numbers. I say 1 and 2. 1 means initial, 2 means final. So the first equation for motion with constant acceleration is this. I write it there. Final velocity, V2, equal initial velocity plus acceleration multiplied by the time difference between initial and final point. Yeah? Now, the 1 doesn't mean the starting point of the motion. The 2 doesn't mean the end point of motion. 1 and 2, the points you chose. You chose a start and finish. Someone else will choose another start, another finish. So I don't want you to think V1 means the start, the very beginning, at the very beginning. And 2 means the end, at the very end. No, any 2. As long as you say, I start here, I finish here. Or I start here, I finish here. So what we call this equation? Equation for a constant acceleration. Good. Now, before I find the second equation, let's go back to average velocity. We said average velocity is delta x over delta t. Displacement over time. Average velocity. The word average here is a little bit tricky. When we say average velocity, we don't mean the average, arithmetic average, okay? I explained this before, but let me emphasize it again. Suppose there is a car moving this way. Here, the velocity number 1, instantaneous, is 10 meters per second. Later on, some other time here, the velocity to 30 meters per second. Another point, V3, and I have 50 meters per second. So it's like you're driving your car. At this point, you look at your velocity is 10. Some other time, 30. Some other time, 50. What are these instantaneous velocities? What's the average velocity of this car? Could you say it louder, please?
Velocity of the final.
This is final?
Yeah.
So you're saying V3 minus what? V1 over time? Okay. Over the time. This is what she said. Any other opinion? So you agree with her?
Yeah, but we can also V2 minus V1.
Any two, you mean?
Maybe it's V2 minus V1, then what we get, we'll get it, will be like V3.
Tell me, what shall I write?
Wait.
You have these three.
V3
V3.
minus
V2 minus V2.
No? Okay. Okay, this is what I wanted to see here. Okay? Now, first of all, the word average generally. When you want to find the average of something, do you have a minus or a plus sign? What do you see here?
minus.
Which means some people think that delta means average. Delta doesn't mean average. Delta is a difference. Average you need to add. Pluses, yes? So delta means the subtraction, the difference between two things. Number one. Number two, if I look at this one, when you say V final minus V initial, what is that? Delta V. When you divide it by T, what is that? Acceleration, yes? Average. So, this is not average velocity. Yes? That's the other reason. So, two mistakes here, yeah? First, a delta is not an average. Second, according to what you said, you're talking about average acceleration. If someone asks you, what's the average acceleration? Of course, you need the time between those 2 points. So this is wrong, yeah? I don't want to see this mistake, that delta equal average. Delta is not average. Now, I was hoping that one of you says that the average here is V1 plus V2 plus V3 over 3. Do you agree with that? Nora? Lena. Lena. So Lena says the V average is V1 plus V2 plus V3 over 3. Yeah? That's what she said, not me. This is another common mistake. This is very wrong. Average velocity is not equal to the averaging of the velocities. It's not like velocity 1 plus velocity 2 plus velocity 3 over 3, or velocity 1 plus velocity 2 plus velocity 3 plus 4 over 4. Because average velocity is not defined this way. Average velocity is defined which way? Change in position over time. It's not the arithmetic average. You cannot add the velocities to get the average velocity. Yes? So this is another common mistake. Average velocity, if you want it, you have to use delta x over. So you need positions, yeah? So here you don't have enough information. You have to know x1, x2, x3, t1, t2, t3. Then you talk about average acceleration. So is that clear? Okay. Since now it's clear, we have one exception. This is possible. So I'm talking now about the exception, not the rule. This is allowed in one condition. If the object moves with, it's allowed. So when you have a problem of motion in one dimension, you have to make sure that first the acceleration is constant to say average velocity is this. But if you are not sure, you can't find average velocity except if you have delta x over delta t. So we write now here, we say average velocity. Here we put a condition. If A equal constant, then what? V average equal V initial plus V final over 2. If you have two values, initial and final, yeah? Look, this is conditional. And a condition, if this is a true, this is what? True. If this is false, this is false. So this is an exception. Exception, velocity average, you can add the two velocities, divide by 2. Is this an exception or a rule, general rule? So I can use it anytime. But this one, especially for constant acceleration. So now I'll write this one underneath. V average delta x over delta t. Now, can I combine now these two? So what is the equation I can find?
If A is constant.
Of course. This is A constant. This is general. Sorry, this one. I can combine them. So when I combine them, the combination is for general or for a conditional, because when you mix special with general, the answer is for special, not for general. Mixing and, yes? Like if you have pure water and salty water. Pure, salty. When you mix them, what's the final? Pure or salty? It affects it, yeah? So it becomes the special, not the general. This is and. In logic, and mixing. It's not an or. If I say this one or this one, no. You have the choice. But and means you put them together. So the special will take over, not the general. So if I combine those two, I'll find delta x over delta t equal v initial, v final over 2. Shall I change the delta t to t?
Yeah.
Possible. So remember, delta t means t. So I'll move this delta. Look at this equation and tell me what's so special about it. There is something not in this equation, something missing. Look, it has initial velocity. It has final velocity. It has time. It has displacement. What is missing? What is missing? What is it? A. Acceleration. This equation doesn't involve acceleration, yes? That doesn't mean there is no acceleration.
It's constant.
No, it means you don't need the acceleration in the equation. Of course, we know the acceleration is constant because this is based on constant acceleration. But do you need the acceleration in this equation? So if the acceleration is not mentioned, you can use this equation to find something. Yeah? If you know any three, you can find the fourth. This is not an equation which we use in equations of motion. This is a conclusion. So this will not be provided in the formula sheet. This one will be provided. This is a combination of these. Yeah? Now, how many equations do I have? This one and the combined one, yes? Yeah. Now I can work some algebra by combining this one to this one. Different ways. I'll come up with the other equations of motion. Yeah? If you are interested, just see the mathematics in the textbook. There is no need that I do it here. It's very simple algebra. You combine. So sometimes you get rid of time in both equations. So you have equation without the time. Or other time you get rid of the final velocity. So you don't have the final velocity in the equation. So when you do these two combinations, you will come up with the second equation of motion, v final square equal v initial square plus twice acceleration multiplied by displacement, delta x. And the third equation, displacement delta x, initial velocity multiplied by time plus half acceleration times square. Okay, now we have the whole set. We have three equations of motion for constant acceleration only. First one, initial velocity, instantaneous. In these equations, we don't have average velocities, instantaneous. Instantaneous velocity initial plus, what is this acceleration? Constant, which means one value, yes? And instantaneous or average are the same. What is this? Well, this is delta t, yes? Between initial velocity and final velocity. Time difference. This equation, initial velocity square plus twice acceleration, which is constant, delta x displacement. Remember, displacement delta x means x2 minus x1. So when here you put delta x, you have to use the positions equivalent to the velocities positions. Yeah? It's not like you take a delta x between 2 points, but you use the velocities on other points. They follow. So when I say v1, it means x1 where you have v1. v2 means x2. Position here and position here. Not any delta x. Number one. Number two, delta x is not a distance. In these equations, we don't have distances. Do we have distance? Or displacement? Are they equal?
No.
So what if I have a question, find the distance? Remember, distance and displacement are equal in one condition. If there is, so first you have to check between those 2 points. If there is no turning point, then you find delta x and you take the absolute value is the distance. But if you find a turning point, no, you have to divide the motion. We'll come to this later on. I'll show you an example. But I just want to emphasize that delta x is not a distance. It's a displacement. Position final minus, and you don't know what happens between those 2 points. And here, displacement equal. What is this? Be careful with this equation. This is initial velocity, not final. We don't have final. Delta t between initial and another final. Acceleration time square. This delta x means you need x1 where you have v1 and x2 is the final point where you have t2. Now these equations for constant acceleration, of course this can be added, but you have to know that equation. But these will be given on a formulation. Right. Now, I want to see now the graphical representation of these equations. First, look at the first equation here. Mathematically, not physically. What do you call this equation in mathematics? Linear equation. Linear. Why? Because the highest power is 1. Now, if you have a function, linear, you have to know the variables, yes? What changes with what? Now, usually you have x and y, your function. So if I take an xy here, function, generally, now not in physics, in math, we have a function y equal. Linear function is y equal mx plus minus c, or sometimes we call it b, but I use c. This is the linear function. What does the m represent? Slope of the line. C, y, intercept. Now here your function is x and y, yeah? Now, if you draw a linear function, if this is x, this is y, how it looks? A line, yes? But it could be this line. It could be this line. It could be this line or this line. So I can fill the space here with linears, yeah? Indefinite numbers. What's the difference between the black line and the red? The slope. The red has a negative and the black has a positive slope. That's the major difference. Now let me take one for simplicity. I take the black one here only. This is a linear function. What does this point represent? The c. And the slope? m. Okay? Now, physics. You said this is linear. Now we have to compare this one to the standard. So I'll write it underneath. V2. I'll switch them. AT plus. Okay, by comparison now. What is my function here? Is it xt? So what is it? Okay, is V1 variable or constant? It's not variable, constant. V1 is the initial velocity, yes? So you have one value. Okay, you don't know how much is it, but it's not changing with time. I start driving the car with 50 km per hour. That's my initial, yes? But what changes with time? The second velocity, the final. So this is constant. Acceleration, constant or variable? Constant. Equation constant. So where are the variables? T is similar to x. V final, similar to. So my function is not xt, is t second v. Of course, I don't put v2, but I mean v at any time, not the initial. V meter per second. So now what's the c in this equation? V1, initial velocity. So the intercept is the initial velocity. And what is the slope? Acceleration. So if you have VT graph, how do you find the acceleration? Find the slope. How do you find the initial velocity? The intercept, y-intercept. Done? This is when it's linear. What else? Let's look at it differently. Now start from a graph. If someone gives you a linear graph of velocity time, what does that mean? The acceleration is what? Constant. When you have a VT graph linear, it means acceleration is? Now if you say no, how many slopes you have here? Which means constant. You have, how many slopes you have in a line? One slope. So constant. So here A is constant but has one value, which is the slope. And this slope could be positive, could be. Now at the moment, acceleration is positive to the right. But if it's that way, negative to the left. Okay. Now, the second equation, if you look at it, it doesn't have time. So it's not time dependent. So we leave this one. We don't need the graph for that. This equation. V1, constant or variable? T, variable. A. So where are the variables? T and V, delta x. Okay. What is this function in math? Quadratic, second degree. Or parabola, if you want to draw it, yeah? This is a second degree. Now, what is the function in math for a second degree? Y, A, x squared, B, x plus C. This is the standard quadratic. Now, if I compare this one to this one, directly is not right. What do you have here, y or delta y? But here? This is not a, this is a difference in position. So open this one up. x2 minus x1 equal v1t plus half at squared. Now move the x1 to this side. You will have x2 equal, and I rearrange this, yeah? I put the square first, half at squared plus v1t plus x1. Still is the same equation. This is a quadratic, yes? Compare it to the standard quadratic. So it's the same, yeah, but compare it as if what represents what? Half at square v1t plus x1. If I draw now x with t, how does it look like? Let's say general, x with y. A general quadratic, how it looks? Parabola, yeah? So it could be this one, could be this one, could be this one, any. I don't know which one, yeah? It's a parabola, second degree. This parabola is physics, it's not math. Is it possible this parabola is this one?
Yeah.
What is the x here? Time. Time. And what is the y? Position. If I want to if I ask you, what is this point? And what's the time?
Negative.
Yeah.
Negative time. So in physics, we don't have negative time. So what you'll see always, your graph is always positive. So there's no such a thing you see a negative part of a parabola. If it's between negative and positive, but if the parabola, all of it here, fine. Part of it, fine, yes? So sometimes what you see, part of the parabola, like this, an object like that. And this is xt function, parabola. Now in a parabola, what does the a means, the b and c? These are the coefficients of parabolas, yeah? If you know them, you know the parabola. If you don't know them, you cannot draw the parabola. But here, when I compare, can I tell how much is a, coefficient a? How much is a, capital? So the coefficients of the parabola, this one, a is half an acceleration, yeah? So the acceleration is twice of the coefficient. What is b? Initial velocity. What is c? Initial position. Now graphically, I made a mistake, x1 here. What does it mean? When time is 0, what is x? X initial, yeah? So this is x1. The intercept, the y-intercept in the parabola is x1, okay? And the coefficient a, it's half of the acceleration. And the coefficient b is the initial velocity. So if you know the values here, then you know the coefficients, yeah? It's a parabola. Now I want you to conclude again. If you have an xt function, and the xt function is a parabola, what can you conclude? Constant. So now you know that. If xt function is a second degree, it means the acceleration is constant. If you have vt function and it's linear, it means constant. Okay? Now think in calculus. If you have xt function to start with, and you derive it, what you'll have? Dx dt. What is that? Velocity. And if you have velocity function, you derive it, gives you acceleration. Now, where is the start? X, yes? Okay, let's say you have an xt function which is parabola. When you derive it, it gives you vt function, yes? Second degree function. When you derive it, becomes linear, first degree. First degree, when you derive it, constant acceleration. So if I want to draw now acceleration with time, how it looks in a constant acceleration? A linear, yeah? Here, if A is positive, but maybe it's here, A is negative. It depends on the slope, yeah? Now, one more thing just to remind you about parabola. If the parabola opens up, what does that mean? This is positive, or A is positive. The square is positive. If it opens down, negative. So you can't tell from there. Of course, when this is negative, it means the acceleration is what? Negative. And what does the acceleration represent here? The slope. So the slope will be? So you expect a line this way. And 80 will be this or this one? Negative, yeah? Okay, so these are linked. Second degree. Derivative first. Derivative constant. Math. So this is a comparison with the math, okay? So all what you need now from all that is that these three equations of motion. These equations, we call them kinematic equations. We'll come to the word kinematic. Kinematics means motion, study motion without looking at the cause of motion. Why the object is moving, we don't know. What's behind it, what are the forces, we call it kinematic. But when you study the motion with the cause, we say it's dynamics. So we have dynamics and kinematics. Huh? So we'll come to that. Now, since we covered motion with constant acceleration, we need a real example of motion with constant acceleration. So I'll talk about freefall. Freefall. What is a free fall? This is an example of motion with constant acceleration, free fall. The word fall, falls, yeah? Okay. Now, when something falls, like the pen, what's the motion here? And how many dimensions is this motion? So this is an example of motion in one. Now, the word falling here doesn't mean always falling. When I throw something up, no, vertically. This is falling as well, because at the end of the day, it goes up and back, so it's falling as well. So free fall doesn't mean you're always falling, no? You can throw something up as well. But you throw it in one dimension, not in 2 dimensions. In 2 dimensions, you'll have motion in 2 dimensions, x and y. Here we just have vertical. So how we define free fall? We say vertical motion under the influence of what? Gravity. Force. Only. So I write it here. Motion, vertical motion under the influence of gravity force only. It's very important, emphasize on the word only. If you are out in space, not on Earth, and you have a pen in your hand, and you throw it this way, will the pen come back? No. Or it goes straight forever? If you throw it this way, straight forever. So is this a free fall? Free fall is that when you have the effects of force on the object. Now if I throw this pen up, How many forces do I have on the pen? Two. Two. What are they? My force, gravity force. Okay. Here there is a misconception. I'm talking about the pen not while it's in my hand. While the pen is in my hand, I am applying a force on the pen. Okay? Is this a free fall now? Where is the free fall? When I open my hand. When I open my hand, the pen goes up. Is my hand going with the pen?
No.
So do I apply a force on the pen? No. So there is no applied force on the pen from my hand. Same. If I throw the pen down, how many forces on the pen? One, not two. Because from here to there, yes, my hand is there. But this is not a free fall. Where the free fall start? When I open? So when I open my hand, there is no applied force on the pen. The pen is under the influence of which force? Only. Force of gravity. Only. That's why we said free fall is the vertical motion under the influence of gravity force only, no other forces. Now, in reality, is that possible? If I throw the pen now, how many forces on the pen? What is the other force? Air resistance. So if I want a free fall, I have to put this condition. No air resistance. No air resistance. Yeah? Always, because here we take the ideal situation. No air resistance. Because if you have air resistance, then it's not a free fall. The word free here means the motion is under the influence of gravity only, free from the effects of other forces. Free from the effects of other forces. Free fall. And how many dimensions we have? One. Okay. So let's say I throw this object up. Now, before I proceed, I know some of you still think that, no, there are two forces when you throw. Because I'm applying a force, yeah? Now, okay, I'm applying a force on the pen, but what I'm doing, my body using this force to transfer energy to the pen. So the moment I open my hand, I don't have a force on the pen. I gave energy to the pen. What type of energy? Kinetics. So that's why it goes up. So there is energy, not force applied. Okay? And the same, when you throw it down, I apply a force up to here to give it energy in terms of like motion, so it comes down with a velocity. Now, when the object goes up or comes down, what happens to the speed of the pen? If I throw it up, when I throw it, initially, do I have a speed or not? Yes or no? Yes. Yes, because how it goes up? I'm talking about the moment it leaves my hand, not here. Up. This is the start of free fall. When I open my hand, the pen has velocity or not? Initially here, yes, V. Okay. What happens to this velocity? Decreases, then stops. And then increases, yeah? Now, be careful. Velocity means magnitude and speed. Are velocity and speed are equal or not? Yes, equal in magnitude, absolute. Okay, but the direction is for velocity. Now, think of speed only here. What happens to the speed when I throw it up? Decreases, which means this is slowing down. Slowing down, yeah? Stops, and then speeds up. Okay, so you have increase and decrease. Okay. Now think of velocity now. What is the velocity when you throw it up? No, positive. Remember, we agreed that right is positive, left is? In a free fall or vertical, up. If the velocity is up, means positive, up. But if the object is pointing down, velocity is what? Negative. So we have velocity up, velocity down. Now I want to think now of in terms of acceleration. If an object is under the influence of a gravity, What we said just a moment ago, we said the speed is changing, yes? So do we have acceleration or not? Because acceleration depends on change of speed or change of velocity. Change of speed means change in the magnitude only. Change of velocity, it means change in magnitude and direction maybe, or one of them. We'll come in details of how to distinguish between those two. But generally speaking, I have acceleration. In a free fall, what do you think? The acceleration of this pen, increasing, decreasing, constant? Regardless, I'm throwing it now. Now, while it's going up, the acceleration is increasing, decreasing, or constant? Constant. Anyone think here it's increasing or decreasing? If you are thinking of increasing and decreasing, you are not answering my question. I'm talking about acceleration, not speed or velocity. What happens when I throw it up? The speed is decreasing, yes? Decreasing. When it's coming down? Increasing. This is speed and velocity. But acceleration is not velocity. It's change in velocity, yes? So this pen, when it comes down, its acceleration is constant or variable? You will say constant. Yeah? Why is constant? How many forces do I have on the object? One force. Force of? Okay. If the force is constant, the acceleration will be constant as well. Again, we'll cover this in Newton's law, second law. Okay. So we have one acceleration. So in a free fall, what can I say? A equal constant. Which way is the acceleration in free fall?
According to the velocity.
No, which way? Usually? Vertical. It could be up or down, yeah, but vertical, yeah? On the y-axis. So the acceleration here, we say A sub y. These equations, we were talking about what? An object moving on the x-axis. So when I say v1, I mean velocity on x1. Velocity final on x. Which acceleration? On x. T, there is no x and y. T is dimensionless, yeah? So this is acceleration on x, yeah? Delta x, displacement on x. But here my motion is up and down. So when I say v, I mean vy. Initial or final? Acceleration. You said it's constant, okay? So this acceleration constant, ay, I'll change it and I call it g. Not ay. And because you said it's constant, it means you know it has one value. What's the value? Meter. But this is the acceleration at sea level. At sea level. G, constant or variable? Yeah, constant. But a reality is not constant. Because the force of gravity is the same when you are at 5 meters above the ground and when you are 2 kilometers above. What happens to the gravity? Decreases. So G will be 9.8 or less. So G changes with height, yeah? How far you are from the floor. But for our course, why? Because we throw things very close to the surface of Earth. So we don't have to take that difference, yeah? But in reality, you can measure G at Corniche in Abu Dhabi. Should be close to at sea level, yeah? But when you go to Al Ain or another city with a mountain, go there and repeat the experiment, you find G is less, 9.7 or just small. But this difference, we don't take it in consideration. So G is constant, we think of it. Now, acceleration, we agreed that has direction, yeah? Positive to the right, negative to the left. Now, where is my motion here? Right, left, or up and down? Okay. So G, when I throw the pen up, is it positive or negative? Why is positive? Is the acceleration of gravity up or down? Why? Because acceleration comes from Gravity, have you seen a gravity up? No. Always down, yes? So even when you throw the pen up, G is down. And when it comes down, G is? So in both cases, what is the sign of G? Minus, because down is minus, up is? So it's not 9.8, it's minus 9.8. So G always 9.8, minus, okay? Not plus. If you land it otherwise, forget it. I can see some students there, they're frowning. It means they land it otherwise, yeah? No. The proper way is G is always negative because it has a direction. And the minus here doesn't mean increase and decrease. It means constant. Okay. So now, can I use these equations for free fall?
Yes.
Yes, because the acceleration is constant, yeah? But I have to adjust them. V1 means V initial on X, yes? But here when I throw, so still V1, yes? Final. A becomes what? We call it G. And G always negative. So I can change this to minus G. So for a free fall, we adjust the equation. The first equation becomes final velocity equal initial velocity minus gt. So how much you put for g here? Plus or minus? No. Because I already put minus. Plus 9.8. I already changed the plus to minus, but just you put 9.8 for g. Second equation. V square, V1 square minus 2g what? Delta x, displacement on x, but here, delta y, displacement vertical. Again, delta y is not height. It's the shortest between 2 points. Third one, delta y, displacement vertical, equal V1t minus half gt square. These are the equations for what? Free fall. Just the a, I changed it to minus g, and the delta x became delta y. So what can go wrong when you apply these? It's the sign, plus and minus. Because this is easy. You have 3, you find the fourth. So the mistakes usually do it with the sign. So V1, initial velocity. If the object at initial point is pointing up, means you put it positive. If it's pointing down, negative. V2 as well, final. See the final point. Is the object going down or positive or negative? Always 9.8. Delta y, be careful with delta y. There is an easy way here to how to find delta y. Let's say you are here. For delta y, use levels, use your hand. Let's say the pen is here at this level. Look, I'm using my hand, level. Not a point, level. You're throwing from this level. If you throw from this level, this is your initial y. When the pen is here, where is the final? Above or below? So you're pointing which way? So delta y is positive. So if you say, this is y initial, and you are here at y final, you are pointing up. So delta y, you use it positive. Let's say now you are here, y initial. Put your hand here. Now I threw the pen. Look at my hand. I threw the pen. This is initial point. Going up, stops, come down to the level of my hand. Now it's here at this level, before it reaches the ground. Where is the second level? Initial, final. Which way are you pointing?
Down.
So delta y is what? How much is delta y? This short distance. You don't take all that. This is distance. Delta y is not distance, it's displacement, the shortest. So here, if this is y final, this will be negative. Okay? I'll stop now to do the quiz, and we continue later on. So this is where we stop. Thank you. Just go to